We will start with the numericals of gravitation. First, we will do the formulae. Now, the formulae are as follows. The first one, which we learned this year, F is equal to capital G M1 M2 upon R square. Here the value of G is, if they don't give you, you have to take it as 6.67 multiplied by 10 raised to minus 11 units Newton meter square per kg square. Now, the second formula is force is equal to mass into gravitational acceleration. Okay, this is in order to find the weight of an object. Now you know force is mass into acceleration. So if I need to find out the weight of an object, I need to find out mass into gravitational acceleration. Okay, don't put this dot because next year you will get confused. You will say teacher taught me the wrong thing. Now, the remaining are my equations of motion which we learnt last year. Okay, equations of motion which we learnt last year. Okay, I'm sure all of you remember that. A is V is equal to U plus AT. Second B, S is equal to UT plus half AT square, and the third formula is V square is equal to U square plus 2AS. Okay, these are my equations of motion. But I must note that for a freely falling body, I hope you can see this green color, for a freely falling body, okay, for a freely falling body, okay, when the body falls from top to bottom, correct, when it falls from top to bottom, okay, my U is equal to 0 and my acceleration due to gravity is minus G, okay, because it is going against the gravity. Gravity takes it, okay. Okay, so we'll take this as G for the time being. For a freely falling body, acceleration due to is the acceleration due to gravity, which you take it as. Now please understand, okay, if my body is going upwards, okay, my G is negative. If it is coming downwards, my G is positive. Correct? So for a freely falling body, when a body is falling from top to down, U is 0. Okay, that is the initial velocity. So my these three formulas can be written as V is equal to GT, S is equal to half GT square, and my V square is equal to 2GS. These are my modified formulas. Okay, I want you to write down these formulas together. Okay, and then we will start with the first question of the exercise. Okay, now that question, let us take it here. The first question is my question 5A. Okay, 5A, the first question. An object takes 5 seconds. So what is given? Right? It is given that an object takes 5 seconds. So my T is equal to 5 seconds. Okay. To reach the ground from a height of 5 meters. So my height is equal to 5 meters. Okay. On a planet. what is the value of G on that planet? They're not telling you the planet is Earth, right? So to find, okay, my value of G, okay, now please understand before we go ahead. An object takes 5 seconds to reach the ground. Okay, so it is going from top to bottom, right? So in that case, my U is equal to 0 meter per second, correct? Okay, now G is not 9.8. G is, it's on another planet. That is why we have to calculate the value of G. Okay, now this H is my height. So see, in my solution, I will say that H is the distance traveled, so that is equal to S, which is equal to 5 meter, which is equal to 5 meter. Okay, now which formula will you use of the three? Now you are taking your G as 0. I told you, for a freely falling body, but I like to always take this extra step, though you can avoid this and straight away go to the formula. S is equal to ut plus half. Okay, I will write it as gt square. Gt square. Therefore, my S is the height, right? So this is 5. My U is 0. So 0 multiplied by 5 plus half into G. For everything they give you, what will you find out, boys? Multiplied by T square. So T square is 5 multiplied by 5, correct? Now which side is my unknown value? It is on the right side, so I always tell you. So this is my 5 is equal to 0 into 5 is 0 plus 25 G upon 2. G upon 2. Okay, so therefore I will say this is 25G upon 2 plus 0. When you add 0, you get the same number. So 25G upon 2 is equal to 5. Because of the lack of space, okay, I'm writing here, I think I have enough space. Therefore, G is equal to 2 multiplied by 5, that is 10 upon 25. That is 5 2s are, 5 5s are. I hope you know this division. I'm just showing you for the benefit of those who don't know. 2 divided by 5. Now my 2 doesn't go in 5, so I'll put a 0 and I'll put a point. First and foremost, please put 2 inside and 5 outside, right? So 5 4s are 20, right? So my answer is 0.4. Units are very important. What are the unit of gravitation? G, acceleration due to gravity, meter per second square, same as acceleration. Okay, therefore please see that you write answer statement, very important in numericals. Okay, value of G on the planet, value of G on the planet equals to 0.4 meter, I hope you can see this, meter per second square, meter per second square. Okay, now this is my first numerical. Okay, not to get scared of these numericals. Now my next one. Let's put a paper. Okay, see my second numerical, right? Second numerical, 5b. Now, I'm reading the question. The radius of planet A is half the radius of planet B. So, what is given to you? Okay, it is given to you that the radius of planet A is equal to half the radius of planet B. Therefore, radius of planet A upon radius of planet B is equal to half. is equal to half. Okay, is this clear? Now, secondly, okay, what am I going to say next? If the mass of A is ma, what must be the mass of B so that the value of G on B, the value of G on B is equal to half the value of G on A. So what we have to find is, we have to find the relation between mass of B and mass of A. So we have to find the relation between G. Now we are going to use this very different formula. Small g is equal to capital G, capital M upon R square. Okay. Now, can I say I have, they have told me very clearly, there is one GA and one GB. So, my GA is equal to, this is universal constant of gravitation. This does not change. I'll keep this as capital G. Now, this is my mass. I want to find out the relation. Here I've used small, no? So, I will say MA upon R A square. And at the same time, if I want to find out GB, I will say this is equal to capital G M B upon R B square. Okay, use the same alphabet here, B and B. Okay, here also this we will use as capital A. Don't change this, right? Therefore, if I have to do GA upon GB, okay, GA upon GB is equal to capital G M A upon R A square divided by capital G M B upon R B square. Now when I am dividing, okay, I have to reciprocal and multiply. Okay, I'm going to the next page, right? So I will say therefore GA upon GB, okay, is equal to, I require GA upon GB, so that is equal to G, okay, this is MA upon RA square. So this is my divided by, okay, I will do multiplied by R B square G upon B, M by B. Now therefore can I cancel this G and G? So therefore GA upon GB is equal to, I'll bring this M A upon M B multiplied by R radius B radius A the whole square. Now boys, just pay attention. See, this is my GA and this is my GB. So here I will write, I want to find out how much is my GA upon GB. I didn't find out in the beginning, but then you said, teacher, why you did like this? Now how much is my GA upon GB? This GB comes down, so this will go on top. So this becomes 2 upon 1. Can I write that? Correct? Yes or no? Now my RA upon RB is equal to half. My RA upon RB is equal, but I want RB upon RA. So therefore, what is my RB, okay, upon RA? my RB upon RA is equal to 2 upon 1. That is equal to 2 upon 1. So my GA upon GB, what is my GA upon GB? My GA upon GB is 2 upon 1. Okay. MA upon MB multiplied by, what is my RB upon RA? My RA upon RB was half, so my RB upon RA is equal to 2 upon 1 the whole square. Now once again, I always keep this rule same. One extra step will happen. So M of A upon M of B multiplied by 4 upon 1 is equal to 2 upon 1. Is that clear? 4 upon 1 is equal to 2 upon 1. Therefore, MA upon MB is equal to, this 4 will go down, it becomes 2 upon 4, which is equal to half. Therefore, if I cross multiply, mass on planet B is equal to twice mass on planet A. This is what I have to give the concluding statement. So I'll write, therefore, mass on A is twice mass on B. Okay, this is my result statement, my answer statement, okay, which is so important in order to get marks in the board exam. Okay, half mark is always reserved for this step. Okay, so mass of B is twice mass of A. Okay, you can write capital M also, no problem. You can write small m, keep the same alphabet throughout. Okay, now we will go to the third sum. Okay, before going to the third sum, I'd like you to solve the fourth sum. Okay, now question number D. Question number D. An object thrown vertically upwards. Now the object is thrown vertically upwards. It's going up. So whenever an object is thrown vertically upwards, wherever it reaches at that height, the final velocity is 0 meters per second, and my initial velocity has some value. It has some value, right? So it reaches a height of 500 meters. Okay, so we will say that given, okay, given height is equal to 500 meter. 500 meter. Okay, 500 meter. Okay, can you see this clearly, this part? Okay, anyway, I'm going to write it out, so it's not a problem. Correct? Then what was its initial velocity? So I have to find my initial velocity. So I have to find u, because you are throwing it upwards, right? Now you tell me what is my g. I explained to you. My g is 10 meter per second square, because you are throwing it upwards, it's against the gravity which works downwards. So it is minus 10 meter per second square. Please see that you take this sign correctly. Okay, what was the initial velocity? How long will it take for the object to come back to the earth? So you have to also find out t. You have to find out u and you have to find out t. So see my solution. Okay, which formula can I use first? Okay, I have h means I have s, so h is equal to s is equal to 500 meter. Okay, yes or no? Now I'll tell you later on about this 500 meter also, right? So can we take, now finally, can you also tell me what is important is that v is equal to 0 meter per second. V is equal to 0 meter per second. So we at least have a v now ready. Now v is equal to, which formula will you use? Okay, you have s, so can I use the formula v square is equal to u square plus 2a s. V square is equal to u square plus 2as. Therefore 0 square is equal to u square, which I have to find out, plus 2 multiplied by, okay, multiplied by a is how much? A is minus 10 and s is 500. Okay, 500. Right now, what I also have to do is I have to take my height as negative, because I'm calculating it, I'm measuring it in this direction, right? So this is minus 500, right? So therefore I can say that u square, okay, 5 2s are 10, minus and minus become plus, okay, okay, plus, okay, no. No, so this you take as, yeah, so this is okay, no, this is not this thing. So u square minus, this will become minus 5 2s are 10, 10 into 1 2, so 1 2 and 3 zeros, okay. And 1 more 0, because 5 2s are 10, right? So this is equal to 0. Therefore u square is equal to 10,000, right? Therefore u is equal to square root of 10,000. Okay, please understand, square root of 100 is 10, 100 is 10, and these two zeros again we put 100 meter per second. Okay, 100 meter per second. Now I have to calculate t. To calculate t, it is very easy. We can use any of the formulas. Can we use v is equal to u plus at? Okay, therefore my v is how much? My v is 0 is equal to u is 100 plus g is minus 10 multiplied by t. So this plus into minus becomes minus, so I'll keep it like that. Therefore 100, I always do this extra step, minus 10t is equal to 0. Therefore minus 10t is equal to, when I take this on this side, it will become minus 100. Therefore t is equal to 10 seconds. 10 seconds. Please write the final answer. Okay, this is my first answer. Okay, and behind I got the other one, right? So my u is equal to 100 meter per second and my t is equal to 10 seconds. 10 seconds. Okay, actually no, now they're asking you how long will it take to come back to the earth. So this is to go up. Okay, so therefore please understand before you write this is t. So therefore they're asking you for total time, they're not just asking you for t. So total time taken, okay, is equal to time for ascent, okay, plus time for descent, to go up and to come down, right? So how much time it takes to go up? It takes 10 seconds to go up, okay, and it will take 10 seconds to come down also. So total time is 20 seconds. Okay, so this is important. So this is my second part of the answer, right? Okay, so after this we'll write the answer. Sorry. Okay, now my sum number E. My sum number E. Okay. Sum number E. Okay. Let's be getting fed up. Okay. Now my sum number. A ball falls off the table. So this is my table, this is my ball, okay, and it is falling off the table, rolling off the table and falling, right? Reaches the ground in 1 second. Okay, so what is given to me? It is given to me that the time taken to reach the ground is equal to 1 second. 1 second. Okay, now assuming that g is equal to 10 meter per second square. Now this is not negative. Why is it not negative? This is not negative, it is a positive value because it is coming down. Okay, it is with the gravity. Okay, so with the gravity, so my g is positive. Correct, my g is positive. These sign conventions are very important, right? Otherwise we'll get our answers wrong, right? Reaches the ground in 1 second, right? Now please remember, when it is reaching the ground, it is leaving from top, right? So my u is equal to 0 meter per second, correct? 0 meter per second. Now I have to find two things. What do I have to find? I have to find the speed on reaching the ground. So I have to find out the final velocity and the height of the table, h, okay, which is also equal to s. I have shown you up till now. H and s are the same, right? Now which formula will I use? I will use my simple formula because I have t. Okay, so I will say solution that v is equal to u plus at. Okay, now my a, I told you I like to write this extra thing. So v is equal to u plus gt. Therefore my u is 0, right? So I could substitute here only 0 plus gt. Okay, so therefore my v is equal to, my g is 10 and my t is 1 second. So my velocity with which it touches the ground is 10 meter per second. Okay, I'll put this in a box and I'll write result, but I also have to write the answer statement. Okay, now what's the next one? The height. Okay, so I can use v square is equal to u square plus 2as, or we can use this formula, we haven't used it. S is equal to ut plus half at square. Once again I like to write this extra step. So my u is 0, so it is 0 multiplied by t is 1 plus half multiplied by a is how much? Okay, is my g, okay, and my t is 1 square, right? But I have to substitute this value. Okay, therefore my s is equal to 0 plus half multiplied by, my g is how much? 10, okay, multiplied by 1. So 2 ones are 2 5s are, so my s is equal to 5 meter. S is equal to 5 meter. I don't have place, but I'm not writing the final step, but you have to write your final step. Okay, you want me to write it on top and show you? You write the answer statement. Answer statement you have to write. Okay, height of the table, height of table, okay, equals to, height of table equals to 10 meter. Okay, height of table equals to 10 meter. Okay, and no, not 10 meter, height of table is equal to 5 meter, sorry, height of table is equal to 5 meter. Okay, and the speed on reaching the ground, so v is equal to 10 meter per second. Height of table is 5 meters, it's 10 meter per second. Answer statement important. Okay, yes or no, right? So now we'll go to the next sum. Okay, next one, see my sum number f. Right? Okay, the mass of the earth and moon, mass of the earth and mass of the moon. Mass of the earth, this even if they don't give you, you must remember 6 into 10 raised to 24 kg. This is the mass of the earth. And mass of the moon is 7.4 multiplied by 10 raised to 22 kg. And mass of the moon 7.4 into 10 raised to 22 kg. The distance between them, so my R is equal to 3.84 multiplied by 10 raised to 5 kilometer. Now this is a very important step. I do not want it's in kilometer. I have to convert this kilometer to meter. So this is equal to 3.84 multiplied by 10 raised to 5. Now you know that 1 kilometer is equal to 1000 meter, which is equal to 10 raised to 3 meter kilometer, right? So I have to multiply this by 10 raised to 3. Did you understand this? I'm rubbing this out only for your understanding. So I will write this as 3.85 multiplied by 10 raised to 5 plus 3. Okay, indices addition. 5 plus 3, 8 meter. Okay, yes or no? And they are telling you that the value of G, I told you, they don't give you have to take 6.67, but here they are giving it to you as 6.7 multiplied by 10 raised to, that does not change. Okay, 10 raised to minus 11. Okay, 10 raised to minus 11 Newton meter square per kg square, right? So because this is meters, I require this unit to be in meters, right? Now what they are telling you to find out, calculate the gravitational force of attraction between the two. So this is my gravitational force of attraction, so this is my capital F. Okay, capital F. Now see the solution, right? This only the calculations are difficult. You remember this formula, F is equal to G m1 m2 upon r square. Remember this equation that we derived, right? Therefore now my F is equal to 6.7 into 10 raised to minus 11 multiplied by mass of the earth. This is my M. I can call this as mass of the earth, and I can call this as mass of the moon, right? So what is the mass of the earth? 6 multiplied by 10 raised, okay, I'll go a little bit that side and move a little this side. So F is equal to 6.7 multiplied by 10 raised to minus 11 multiplied by mass of the earth, 6 into 10 raised to 24 multiplied by mass of the moon, 7.4 multiplied by 10 raised to 22. Okay, 10 raised to 22 upon r square, that is equal to 3.85 multiplied by 10. This is 84 and not 85. I don't know why I made it 85. It's 10.84. Sorry. Okay, 10.84, right? Multiplied by 10.84. Okay, into 10 raised to 8. Okay, the whole square. Okay, now this is little khatarnak calculation, right? Look at this. 6.7. Okay, I'll bring all this 6 close by. I'll bring this 7.4 close by, multiplied by, now look at this, 10 raised to minus 11 and 24. Signs are different. Subtract and put the sign of the greater number. So 24 minus 11 is 13. Okay, and plus 22. 13 plus 22 is 10 raised to 35. Okay, 10 raised to 35 upon 3.84 multiplied by 10 raised to 16. 10 raised to 16. Okay, is this very clear? This is my 10 raised to 16. Is this very clear? Okay, now I want to remove this decimal points, right? So I am just taking this. I have to take a new page because calculations are plenty here. Okay, so here just see. So I'm just copying this last step phi f is equal to, I'm repeating that last step, 6.7 multiplied by 6 multiplied by 7.4, okay, 7.4 multiplied by, I'm copying this, 10 raised to 35, okay, upon, okay, this is 3.84 the whole square, so even this is 3.84 the whole square. So what does this become? This becomes 3.84 multiplied by 3.84 multiplied by 10 raised to 16. This is my 35, right? This is my 35. Therefore, f is equal to, now I want to remove those decimal places, okay, I want to remove those decimal places, so I will say one place here and two places here, so these two will go away, so this becomes 67 multiplied by 6 multiplied by 74, right? This is one place and this is one place, 2, so this goes away, so this becomes 384. Now if I want to remove this decimal place 384, I have to multiply by 10 raised to 2 in the numerator, right? Multiplied by 10 raised to 16, 10 raised to 16, okay. Multiplied by, no, 1 minute, this is 10 raised to, this is my 10 raised to 35, okay, multiplied by 10 raised to 16, 10 raised to 16, correct? Yes, ma'am. So now when I minus this 30, okay, so pay attention, this is now, just see this, okay, so this becomes, I'm going to multiply 67 into 6 into 74. I'm not really this thing with your multiplication, that is 29 748, okay, and when I multiply 384 into 384, if you multiply 384 into 384, 14 7 7 4 5 6, this is simple multiplication, multiplied by, now this becomes 37 and this 16 down, so I'll minus 16, so I'll get 21, so multiplied by 10 raised to 21, okay, 10 raised to 21. Now actually I have to do long division of this, right? I'm just taking a rough page out here because it's very difficult otherwise. I have to do long division. What do I have to divide? I have to divide 29 4 7 4 8, correct? I have to divide it by 14 7 4 5 6, okay. Now see this, 29,748, 1,47,456, right? So what I will do is, I'm making it still easier for you, I'm writing 29 7 4 8, I will pull one 0 from here, correct? So this will become 10 raised to 20 because I pulled the 0 upon, this is my 1,47,456, right? Now I will pull one 0 here. Now if I see my tables, I think this will go 2 times, right? So if I multiply this 2 times, 6 2s are 12, okay, 5 2s are 10, 11, 4 2s are 8, 9, 7 2s are 14, okay, 7 2s are 14, 4 2s are 8, 9, 2 1s are 2, so 2 9 4 9 1 2, okay. When I minus this, okay, this will become 8, this will become 6, this will become 4 and 5, this will become 3, okay, 3 5 6 8. Now I will put my decimal point here and I'll bring down the next 0. 35,680, and this is 4 1,40,000, so this becomes 0, right? And I'll put one more 0. Okay, if I see the decimal place, okay, this is 37 3,56,800, 3,56,800. Okay, and I don't actually have to find out. This is 2.0, so I take it. They're not. But now you have to see this answer. So when I divide it, I got 2.0. Okay, so I don't bother, multiplied by 10 raised to 20. Now force, this is my force. So what is my unit? My unit is Newton. My unit is Newton. Okay, so the calculation of this is a little difficult, right? But that's how it is supposed to be. Okay. Okay. Now next one. Again, result statement you have to write. Result statement. Now see my sum number G. Okay, sum number G. The mass of the earth is, I told you, I actually have to remember the mass of the earth, right? So what is given to me is the mass of the earth, right? The mass of the earth is equal to 6 multiplied by 10 raised to 24 kg. 6 into 10 raised to 24 kg, the mass of the earth. And the distance between the earth and sun, so my radius is equal to 1.5 into 10 raised to 11 meter, right? 10 raised to 11 meter. If the gravitational force between the two, so F is equal to 3.5 multiplied by 10 raised to 22 Newton. What is the mass of the sun? And once again they are telling you G is 6.7 into 10 raised to minus 11 Newton meter square per kg square. Okay, so we have to find, okay, the mass of the sun. Okay, the mass of the sun. Again, the calculation is lengthy. Okay, but we can start with the formula, not to get scared of the formula. See my solution. Okay, my force is equal to G m of E upon m of S upon R square. Okay, so okay, this is okay. Now what is my force? My force is 3.5 multiplied by 10 raised to 22 is equal to 6.7 multiplied by 10 raised to minus 11 into 6 into 10 raised to 24 multiplied by mass of the sun upon radius is 1.5 multiplied by 10 raised to 11 the whole square. Okay, now see, my mass of the sun is here. So as usual I told you, I'll take 6.7 multiplied by 6 multiplied by mass of the sun multiplied by 10 raised to 24 minus 11 is 13. Okay, upon, okay, this is my 1.5 multiplied by 1.5 multiplied by 10 raised to 22 is equal to 3.5 multiplied by 10 raised to 22. Now see this. Okay, now I want to find out the mass of the sun. This is my unknown value. Okay, so once again I bring another page. I will write my mass of the sun, 3.5 multiplied by 1.5 into 1.5, okay, multiplied by 10 raised to 22, which is already here, and I took this 10 raised to 22 on top, so it becomes 10 raised to 22 upon, here 6.7 multiplied by 6 multiplied by 10 raised to 13. Now my solving is the only problem. This is very easy sum. Okay, I'm doing this to not to confuse you. Okay, because I have everything out here. Okay, can you see this? Focused well. Okay, so this is equal to, okay, therefore the mass of the sun is, now remove the decimal places. This is my 35, correct? This is my 15 and this is my 15. I'm leaving those tens out for the time. This is my 67, correct? Now here this had nothing, na? So this is 6. So I make it 60 and I will write into 10. Okay, let's see how it works out. Multiplied by 22 plus 22 is 44. 44 minus 13. 44 minus 13 is 31. Okay, so into 10 raised to 31. Okay, let's see how this cancels. Let's see how this cancels. Right? So now 15 ones are, 15 fours are. Okay, this will be okay. So let's not touch this at all. So this becomes 35 multiplied by 15. Okay, once again this is 10, this goes on top, so it becomes 30. Okay, upon 67 multiplied by 4. Okay, now 35 multiplied by 15. 15 5s are 75. 5 down, carry 7 up. 15 3s are 45 plus 7 is 5 to 5. Okay, upon 7 4s are 28. 24 26, correct, multiplied by 10 raised to 30. Okay, so once again we are left with our long division. Okay, we'll go back to this rough page of mine and we'll divide okay, 525 by 6 to 8, 6 by 268, right, by 268, by 268, 268 multiplied by 2, 250 multiplied by 2 is 500. Okay, so this is only one time still, right, by one time it is 268, right? So when you minus this, okay, this will become 7, okay, this will become, okay, 6 5, this will become 257, correct? Now because that I'll put a point and I'll put a 0. Now obviously this will be 9 times, okay, 9 times, okay, 9 times when you multiply, 8 9s are 72, 6 9s are 54, 54 plus 7 is 61, 18, 19, 20, 21, 22, 23, 24. Okay, 2, 4, 1, 2. Okay, minus this you get 8, this you get 6 minus 1 is 5, and this is 1. Okay, now this will be 6 times. Okay, so you get 196 into 1.96. Okay, you have to do long division. Okay, 1.96 multiplied by 10 raised to 30. This is the mass of the sun, so that is equal to kg. Please write the answer statement. Please write the answer statement. Okay. Now, I also want to do for you question number 4. Okay, question number 4. Okay. Now it's a sort of derivation. If the period of revolution of a planet at a distance of r from the sun, okay, if the let the period of revolution, so I'm showing you this question, okay, can you see it? Okay, and anyway, read it in your textbook. Let the period of revolution of a planet at a distance r from a star be t. Prove that if that If it was at a distance of 2 hours from the star, the period of revolution will be root 8 multiplied by t. Okay, prove that distance was. Okay, so what is given to you is that my second distance, that is my r2, is equal to twice the first distance, that is r1. Okay, and so we have to find out the period of revolution, right? So now to find, okay, actually to prove that, okay, the period of revolution, okay, that means t2 is equal to root 8 multiplied by t1. Okay, now see how we will write this proof or the derivation. Okay, now we know using Kepler's third law, okay, using Kepler's third law, okay, square of the period of revolution is directly proportional to the cube of the distance, right? So therefore t square is equal to k into r cubed. Now if I say t1 square k into r1 cube and t2 is equal to k into r2 cubed. Therefore, very easy, t1 square upon t2 square is equal to k multiplied by r1 cube upon k into r2 cubed. Now I'll cancel this k and k, right? I want to find the relation that t2 is root t. Now this is r1 upon r2, so you say but r2 is equal to twice r1. Therefore r1 upon r2 is equal to 1 upon 2. 1 upon 2. Therefore t1 square upon t2 square is equal to 1 upon 2 the whole cubed, which is equal to 1 upon 8. Okay. Now, therefore, can I go here? Take a new page. So therefore, look at this. Therefore, t1 square upon t2 square is equal to 1 upon 8. I just copied that step again. These are long sums, so it's very difficult for me to use the same. Okay, therefore t1 upon t2 is equal to square root of 1 upon 8. Okay, therefore this is 1 upon root 8. Okay, you could find out square root of 8 as 2 root 2, but they have not asked you, so leave it like that. Then you cross multiply. t2 equals to root 8 multiplied by t1. Okay, that's what I have to prove. Root 8 into t1. Okay, so t2 is equal to root 8, okay, multiplied by, okay, the original time they have taken as t, so we will take this as t. Okay, you could take it as t1 also, you can take it as t also,